Hello students, this is a video on the topic tests available for Quant and Bodhee Prep. The idea of these tests is once you have gone through a topic, you want to ensure that you're able to do the questions in the exam or that topic is done for you. That is where you take this test. You complete a topic, take the test. With every test, there is a video which gives you the solution and a brief analysis of what would be a good attempt for the test. There are more than 200 topic tests available on the Bodhee Prep Android app. Make sure to download the app and make the most of these tests. This video is on the topic probability, and this is test number 2 that we're discussing. Overall, I think moderate to difficult level of tests. 5 questions net correct in about 23 minutes would be a good attempt, which would get you 95+%. If we look at the questions, the first one says a fair die tossed until 6 is obtained on it. Now, probability of getting a 6 is 1/6. Probability of not getting a 6 is 5/6. Let x be the number of required tosses in the conditional probability that p is great x, probability that x is greater than or equal to 5 given x is greater than 2. Now, what will be the probability of x greater than or equal to 5? If the 6 appears in 5 or more tries, that means if suppose it appears in the 5th try, the first 4 tries will not have a 6, the 5th try will have a 6. Or what will happen is the first 5 tries will not have a 6, the 6th try will have a 6. Or the first 6 tries will not have a 6, the 7th try will have a 6, and so on up till infinity. So probability of x greater than or equal to 5 is, this becomes a GP with the first term being 5/6 raised to power 4 into 1/6. Common ratio is 5/6. So a upon 1 minus r. This will become 1/6. So 5/6 raised to power 4. What is the probability that x is greater than 2? So we should not get a 6 in the first 2 tries, which means 5/6 raised to power 2. In the third try, we can get a 6. If this does not happen, we will not get 6 in the first 3 tries. Fourth try, we'll get a 6, and so on up till infinity. So this will become 5/6 whole square into 1/6 a upon 1 minus r. So this will be 5/6 whole square. And therefore, the required probability will be 5/6 raised to power 4. The 6 appears in more than equal to 5 tries upon given that it appeared after the second try. So this value upon this value. This will give us 5/6 raised to power 2, which is nothing but 25/36. Option D becomes the answer. I think moderate level of difficulty, though it says conditional, even if you separate the two probabilities and divide them, we get the answer. No need to get into the entire formula for conditional. Basic understanding will give us the answer in about 2 to 2.5 minutes. Two fair die are thrown, the numbers on them are taken to be lambda and mu, and a system of linear equations is defined. If P is the probability that the system has unique solutions, Q is the probability that the system has no solutions, then. Now, first of all, we'll reduce it to a system of two variables. So what I'm doing is, I am subtracting the first equation from the second equation. X cancel, 2y minus y is y. 3z minus z is 2z. This is mu minus 5. This becomes equation 1. Then we are subtracting the first from the third. X cancel, 3y minus y is 2y. Plus lambda minus 1z. 1 minus 5 is minus 4. Now, P is the probability that system has a unique solution. Unique solution happens when A1 upon A2 is not equal to B1 upon B2. Here 1 upon 2 should not be equal to 2 upon lambda minus 1. 2 upon lambda minus 1. So lambda minus 1. P is the probability that system has unique solution. Okay. So lambda minus 1 should not be equal to 4. So lambda should not be equal to 5. What is the probability that lambda is not equal to 5? The probability that lambda is not equal to 5 will be 5 by 6 because we are getting this from a throw of a dice. It should not be 5. It could be any one of the other 5 numbers. So for unique solution, we get P is equal to 5 by 6. Q is probability that system has no solution. For no solution, A1 upon A2 should be equal to B1 upon B2. Slope is same, intercept should be different. 1 by 2 is equal to 2 by lambda minus 1. From here, we can say lambda is equal to 4, 5. And further, from here, we can say 1 by 2 is not equal to mu minus 5 by minus 4. So, mu minus 5 should not be equal to minus 2. Mu should not be equal to 3. Lambda is equal to 5 will happen 1 by 6 ways. Probability of this happening. Mu not equal to 3 can happen in 5 by 6 ways. Both of them happening together, Q will be 1 by 6 into 5 by 6, that is 5 by 36 becomes the answer. The probability P is 5 by 6, probability Q is 5 by 36. I think this is a relatively easy question in terms of concept. There are 3 different concepts involved, but all of them are basic concepts. The numbers are also manageable, so about 2 to 2.5 minutes to solve. When a certain biased die is rolled, a particular face occurs with probability 1 by 6 minus x. Its opposite face with probability 1 by 6 plus x. All other 4 faces, 4 will remain, have a probability of 1 by 6. Note that the opposite faces sum to 7 in any die, or at least in this one. If x lies between 1 and 0 and 1 by 6, find the probability of obtaining total sum 7 when such a die is rolled twice. The probability of getting a 7 is 13 by 19. Find the value of x. Now, suppose there are 4 faces which are not biased, have a probability of 1 by 4. The 5th and 6th faces is biased. Suppose in the first try, the first phase comes up. To get suppose 1 and 2 are opposite faces, 3 and 4 are opposite faces, 5 and 6 are opposite faces. To get a sum of 7, we'll have to have the opposite face. So the next has to be phase 2, probability 1 by 6 into 1 by 6. Suppose in my first try, second phase comes up. To get a sum 7, I will need phase 1 in the next try. So again, 1 by 6 probability. In the first roll of the die, if the third phase comes up, probability 1 by 6, we will have to have the fourth phase to get a sum of 7. If the fourth phase turns up, we'll have to have phase 3 to get a sum of 7. If the fifth phase turns up, which has a probability of 1 by 6 minus x, we will need 1 by 6 plus x. If the sixth phase turns up 1 by 6 plus x, we will need 1 by 6 minus x. This is the probability of getting the sum as 7. This is given as 13 by 96. So 1 by 6, 36, 4 by 36, 1, 2, 3, 4, plus 2 into 1 by 36 minus x square. A plus b, a minus b 2 times. 13 by 96. 2 into 1 by 36 minus x square is equal to 13 by 96 minus 4 by 36. This is 6 into 6, 6 into 16, 12 into 3, 12 into 8. So 12 into 3 into 8, 12 into 3, 12 into 8. The LCM is 12 into 3 into 8. 39 minus 339 minus 8 4 32. So this becomes 7 by 12 into 3 into 8 divided by 2, and therefore 1 by 36 minus x square is equal to 7 by 36 into 16. This means x square is equal to 1 by 36 minus 7 by 36 into 16, which means 16 minus 7 upon 36 into 16, which means x square is equal to 9 by 36 into 16. 9 fours are 36, which means x is equal to 1 by 2 and 1 by 4, which is 1 by 8. Taking the square root, basically x square comes out to 1 by 4 into 16, taking the square root. Square root of 4 is 2, square root of 16 is 4. So 1 by 8 becomes the answer of option number 2. Again, in terms of level of difficulty, I'd say moderate. We're just writing the probability and then solving for the equation. 2 to 2.5 minutes to solve. Each of the persons A and B independently tosses 3 fair coins. The probability that both of them get the same number of heads. The number of heads that they get could be 0, 1, 2 or 3. Since 8 coins are tossed, we could have TTT, TTH, THT, THH, HTT, HTH, HHT, HHH. Probability of getting 0 heads is 1 by 8. 1 by 8. This one out of a total of 8 cases. Getting 1 head is 1, 2, 3, 3 by 8. Getting 2 heads is 1, 2, 3, 3 by 8. Getting 3 heads is this 1 by 8. So if A and B both get 0 heads, the probability will be 1 by 8 into 1 by 8. Both get 3 heads, probability will be 3 by 8 into 3 by 8. Both get 2 heads, probability will be 3 by 8 into 3 by 8. Both get 3 heads, probability will be 1 by 8 into 1 by 8. So this becomes a required probability. This happens, or this happens, or this happens, or this happens. So 8 8s are 64. 1 plus 9 plus 9 plus 1. 20 by 64 divided by 4, 5 by 16. Option 3 becomes the answer. I think this question would be an easy question. A minute and a half to solve. An electric instrument consists of 2 units. Each unit must function independently for the first instrument to operate. The probability that the first unit functions is 0.9 and that the second functions is 0.8. So probability of first functioning is 0.9. So probability of the first not functioning is 0.1, 1 minus 0.9. Probability of the second functioning is 0.8. Probability of the second not functioning is 0.2. Instrument is switched on, it fails to operate. If the probability that only the first unit failed and the second unit is functioning is P, 98P is equal to. Now, suppose uh, if the unit does not operate, probability of not operation could be because not or no operation, not operation. Probability of no operation could be because A did not work, but B worked. One did not work, two worked. One worked, two did not work, or both one and two did not work. We can also say 1 minus both 1 and 2 working. This becomes 0.1 into 0.8, 0.9 into 0.2, 0.2 into 0.1. This is 0.08 plus 0.18 plus 0.02, so 0.28. This is the probability of no operation. Now it says the operation did not happen because only the first unit failed. So we are looking at this case. Only the first unit failed, the second was working. So the probability of this happening would be 0.08 upon 0.28 or 8 by 28 divided by 4, 2 by 7. This becomes the value of P. We have to find the value of 98P. So 98 into 2 by 7, 7 14s are 98, and therefore the required answer becomes 28. Part of conditional probability here, moderate level of difficulty, the numbers are easy, therefore about a minute and a half to 2 to solve. Let S be comprise a set of elements 1, 2, 3, 4, 5, 6. Probability that randomly chosen onto function. Onto means all the images should have a pre-image. There should be no element in the range that should be empty in that sense. It's an onto function. G from S to S. So we are defining a function from S to S. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. What is the total number of functions that can be determined? This one could have any one of the 6 numbers assigned. So 6. This 2 could have any one of the remaining 5 numbers assigned. 5. Similarly, 4. This will have 3 options left. This will have 2 options left. This will have 1 option left. So 6 factorial total functions can be defined. It is given that G3 is equal to 2G1. Now, G1 could be 1, which will give G3 as 2. In this case, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. When G1 is 1, so the domain or X is 1, independent variable, dependent variable is 1. G3 is mapped to 2. Now there are 4 elements remaining here, 3, 4, 5, 6. From these, we can make 4 factorial 4 factorial functions can be defined like we did here. Similarly, if we take G1 as 2, G3 would be 4. Again, defining the functions 1, 2, 3, 4, 5, 6. Domain and codomain 3, 4, 5, 6. G1. G1 is mapped to 2. G3 is mapped to 4. There are 4 elements remaining 1, 1, 3, 5, 6. From here, we can define 4 more functions, 4 factorial functions. Similarly, if we take G1 as 3, G3 will be 6. In this case also, we will be able to define 4 factorial functions. G1 cannot be taken cannot take any higher value because then G3 will cross 6, but that is the highest number we had. Therefore, favorable cases will be 4 factorial, 4 factorial, 4 factorial, or 3 into 4 factorial. 3 into 4 factorial, and therefore probability of this happening will be 3 into 4 factorial upon 6 factorial. This is 3 upon 6 into 5, which is 1 by 10. Option 1 becomes the answer. This is definitely a difficult question, almost on the lines of JEE Advanced, or at least that entrance level. This has functions, probability, both of them included. If we know what we are doing, maybe 2.5 to 3 minutes to solve, but probably not something that we look at in the exam. 2 squares are chosen at random on a chessboard. The probability that they have a side in common. Now we can look at the edges first, or the corners first. Here there are 2 options. So I say 4 corners, and 2 choices possible, this or this. Similarly for each corner. Then we look at the edge, 1, 2, 3, 4, 5, 6. For the edge, we have 1, 2, 3 options. So 6 squares in the edge, 3 options for each square, and there are 4 such edges. Then we look at the remaining squares, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 36 squares are left inside. For each of the square inside, we have 1, 2, 3, 4 options, common side. So 36 into 4. Also, you will realize that every choice has been counted twice. When I count these two from the corner, the it will also be counted from the edge from here. So what I'm saying is total number of choices such that a side is common will be 4 into 2, 8, plus 24 into 3, 72, plus 144 by 2. This is 80, 224 by 2, 112. And the total number of possibilities will be 64 C2. 64 boxes are there. We are choosing any two. So 64 into 63 by 2 or 32 by 63. Therefore, the probability of becomes favorable cases upon total number of cases. Dividing by 7, this is 9. This is 16. 16 twos are 32. So 1 by 18. Option 2 becomes the answer. Again, in terms of level of difficulty, I'd say this is an easy to moderate question. Should not take more than a minute and a half to maximum 2 minutes to solve. Let x be a random variable with distribution x minus 2, probability is 1 by 5, x minus 1, probability is a, x is equal to 3, probability is 1 by 3, x is equal to 4, probability is 1 by 5, x is equal to 6, probability is b. If the mean of x is 2.3, variance of x is lambda square, you have to find 100 into variance. First of all, we have to find value of a and b. The first thing is sum of probability should be 1. So 1 by 5 plus a plus 1 by 3 plus 1 by 5 plus b should be equal to 1. This becomes a plus b is equal to 1 minus 1 by 3 minus 2 by 5. So this becomes 15. 15 minus 3, 5. 5 minus 6. 6, 5, 11. A plus b. So a plus b is equal to 4 by 15 becomes my first equation. Second, mean is 2.3. Mean is given by sigma xi pi. Therefore, I will say minus 2 into 1 by 5 xi pi plus minus 1 into a plus 3 into 1 by 3 plus 4 into 1 by 5 plus 6 into b should be equal to the mean, that is 2.3. This becomes minus 2 by 5 minus a plus 1 plus 4 by 5 plus 6b is equal to 2.3 can be written as 23 by 10. So this will become minus 1 by 5, 4 by 5, 2 by 5, 7 by 5, and from here we can write a plus 6b is equal to 23 by 10 minus 7 by 5. 7 by 5 is 14 by 10. Therefore, a plus 6b is equal to 23 minus 14. 9 by 10 minus a plus 6b. This is negative, this is positive. And a plus b, 6b, a plus b we know is 4 by 15. If we add these two, we will get 7b is equal to 9 by 10 can be written as 27 by 30. This is 8 by 30. 35 by 30, or b comes out to 1 by 6. This is 1 by 6. And from here we can say a is equal to 4 by 15 minus 1 by 6, which is 8 by 30 minus 5 by 30, or 3 by 30, or a becomes 1 by 10. Now we'll find out the variance. Variance is simply sigma pi xi square. This is a formula that pi xi square minus the square of the mean. This is the formula for variance. So this becomes 1 by 5 into 4, 2 minus 2 square, plus 1 square minus 1 square into a. So a plus 3 square, 9 into 1 by 3, so 3, plus 16, 4 square, 16 by 5. 16 by 5 plus 36 into 1 by 6, which is 6. A was 1 by 10, so we can write it as 1 by 10. Minus uh, mean was 2.3 or 23 by 10 square. This becomes 4 by 5 plus 1 by 10 plus 3 plus 16 by 5 plus 6 minus 23. 23 into 23 is 529. 529 by 100, which becomes 100 into 2080 plus 10 plus 300 plus 320 plus 600 minus 529, which further becomes 80 plus 10, 90 plus 300, 390 plus 320, 710 plus 600, 1310 minus 529, 1310 minus 500, 810, 810, 790, 781, 781 upon 100. So the value of variance is 781 upon 100. We have to find the value of 100 square. This is nothing but 781. This becomes my answer. Again, in terms of level of difficulty, difficult question, hardcore probability distribution, uh, easily 2.5 to 3 minutes to attempt, even if you decide to attempt it at all. The probability that two randomly selected subsets of the set 1, 2, 3, 4, 5, exactly two elements in their intersection. Suppose the subsets are A and B. For each element, there are four possibilities that it will be in A and it will be in B. So it is common to both of them. It will not be in A, it will be in B. So it is not common. It will be there in A, not there in B. Again, so it is not common. It will be absent in both of the sets. Again, not common. So this is a favorable case. These three are not favorable cases. Each of the element has four options. So the total number of subsets or total number of possibilities that we get, these are the four options, is 4 raised to power 5. What are the favorable cases? We need exactly two elements in the intersection. So favorable elements will be, we choose two out of these five elements. These two are common. So for them, this case, only one case is possible. That is, they have to be in both the elements, both the subsets A and B. For the other three elements, one of these three cases will happen. So 3 into 3 into 3. These are the two common elements which have been chosen in 5C2S. For the remaining three possibilities are there. Either they will be in the set A, not in B, not in A, in B, or not in both of them. And therefore the probability becomes 5C2 is 5 into 4 by 10. 10 into 3 into 3 into 3 upon 4 raised to power 5. Which further becomes 2 into 3, 3, 9, 9 5s are 27 into 5. 135 upon 4 raised to power 5 is 2 raised to power 10. So 135 upon 2 raised to power 9. Option 3 becomes my answer. Again, I would classify this as a difficult question. Making these four cases and understanding is I think, a challenge. Once this happens, the question might happen, but not something that you would be able to do for the first time in an exam, probably. An ordinary dice is rolled for a certain number of times. If the probability of getting an odd number 2 times is equal to probability of getting an even number 3 times. Suppose the dice is rolled n times, what is the probability of getting an odd number twice? probability of getting an odd number, first of all, is 1 by 2. Probability of getting an even number is 1 by 2. If you're looking at probability of getting two odds out of n tries, again, this becomes a binomial event, odd or even outcome. So NC2 into 1 by 2 raised to power n. Probability of getting three even number three times will be NC3. Again, 1 by 2 raised to power n. This is given to be equal. Therefore, NC2 is equal to NC3. This will happen when n is equal to 2 plus 3, which is 5. NCR is equal to NCn minus R. So the number of times that the dice is being rolled is 5. We have to find out the probability of getting an odd number for odd number of times. Getting an odd number for odd number of times. So odd number could be there once, odd number could be there twice, odd number could be there thrice. The probability for this will be 5C1, 1 by 2 raised to power 5. No, sorry, 3 times or 5 times. Odd could be once, thrice, odd number of times. This will be 5C3, 1 by 2 raised to power 5. This will be 5C5, 1 by 2 raised to power 5. Either this happens or this happens or this happens. And therefore, overall probability becomes 5C1 plus 5C3 plus 5C5 into 1 by 2 raised to power 5. 5C1 is 5. 5C3 is 10. 5C5 is 1 upon 2 raised to power 5. This means 16 upon 32, which is nothing but 1 by 2 becomes my answer, option number 4. Moderate to difficult question. Understanding the question might be a little bit of a challenge. From there, probably doable, about 2 minutes to solve. If you look at the overall test, I think difficult set, and we're looking about 5 to 6 questions. For me, these questions will be 1, 2, 3, 4, 5, 10. Which are these? So definitely doing this one. Again, don't read the word conditional. This question is not difficult. This is again basic concepts attempting. This also, I think, was a basic equation formation question, so would have been attempted. This, I think, was the easier amongst the questions that were given. Simple cases, 3 coin tosses, so not very difficult. Would have attempted this as well because numbers are easy. I thought this question was difficult. Will not attempt this because requires extensive knowledge of function. This question again, there is a very good chance of a mistake happening. The question is not very difficult, but chance of mistake happening are very high. Missing out on dividing by 2, getting the wrong number of squares, or forgetting the side and looking at the diagonal. A lot of possibilities for mistakes. So not counting this as a sure shot question. Again, this is probability distribution, would not have attempted it in the exam. This question also, I think, making the first 4 cases was a challenge. So not an exam question probably. This, I think, I would have done in the exam because I've done this question, similar question earlier. So once you know what you're doing, it becomes pretty easy to solve. So 1, 2, 3, 4, 5, and 10. Someone might say, I would do 7 instead of 10. Well and good. But there are clearly 5 to 6 questions that can be done in about 23 minutes to get a 95+%.